Welcome to Chapter 15 on component patterns and mirroring. We're going to take a look at this bicycle assembly again for a couple of reasons. There are some nice patterns in here and some instances of mirroring that can be instructive. The first pattern I want to take a look at is in one of the wheels. Let's open up this wheel and see how the spoke patterns were created. Spokes were created in a circular pattern, but if we look closer at the spokes, we notice that they're not all the same. On each side of the hub, we have two spokes that are patterned again and again. And if we look across the hub, these spokes do not line up perfectly, so they cannot be mirrored straight across the hub. So what we have is a four-spoke pattern that has to be created in a circular pattern. These four spokes have to be put together manually. Plus, two of the spokes, if we look at these, have different angles. For example, if one spoke comes from the outside and the other one comes from the inside, in order to reach back to the center of the wheel, the spokes need to be angled slightly different. So we have configurations of the spokes in addition to the pattern. Let's take a look at how this was created. If we open up the pattern, we have four spokes that were initially manually assembled, and then 8 instances of those four spokes will give us a 32 spoke pattern for this front wheel. If we switch back to the assembly with Control Tab, the rear wheel also has a circular pattern, but notice that it's slightly different, because if you look at the sprocket, it creates an offset, but the wheel still has to go into the center. So the spokes are not symmetrical on the rear wheel. The spokes on the drive side have to be tighter than the spokes on the non-drive side in order to create this dishing effect. So it's still, when we look at the pattern, it's still a four-spoke pattern, but now instead of having two different configurations, now we have four configurations, because each one of the spokes has a distinct angle to reach from the hub flange to the rim. There are a lot of considerations when you put together patterns in assemblies in SolidWorks. One of the things that you want to be careful about is that you don't make patterns of components with in-context relations. You also don't want to make patterns that reference assembly features or features from an assembly outside of the current assembly. For example, with these spokes, the patterns were all made around the axis of the hub. We didn't make the pattern around the axis relative to, say, the fork or something like that. You want to keep all of the references as close to home as possible. When you start going outside of the local assembly to make a reference, you're going to slow down the function of the assembly by requiring SolidWorks to open more parts. Let's take a look at another pattern that we've seen before, but this is an assembly level pattern rather than a sub-assembly level pattern. We looked at the chain pattern. We've put a sketch in here that represents the line of the chain. It goes around the big chain ring in the front and the small sprocket in the rear. And as we've talked about before, it's a planar sketch line, so it doesn't necessarily line up the way the real chain would. And the real chain has some flexibility to it, so it would flex in and out. The pattern was created in the following way. You start with two links. In this case, we had an inside and an outside link. Let's create this from scratch. I'm going to copy out two links, and then I'm going to delete the chain pattern. To create the chain link pattern, we go to Insert, Component Pattern, Chain Pattern. There are several different methods for the pitch. If you have a single link that's both the inside and the outside link, then you pick the first one. If you only have the outside link and you want to represent it as an inside-outside type link, then you pick the second one. But if you have inside and outside links, then you pick the third one. That's what we want to create. I'm going to select the chain path, which is this sketch. But if I just select it in that way, I'm only going to get the single arc, and I want the whole thing. So I'm going to right-click, go to Selection Manager, make sure it's set to Select Closed Loop, and select the entire sketch loop and right-click. That's what the Selection Manager option here is for. You don't have to right-click in space to get that. You can just use the selection in the Property Manager. Chain group number 1 will be one of the types of links that you have. So I'll select here the outer, and then it wants one end of the link. So I'll go in and select the inside face here. Then it wants the other end. I'll select this face here. And the path alignment plane, let's take a look and get this out of the way. In the outer link, I want that to be the right plane. And make sure that's the correct plane. No, it'd be the front plane. And just to zoom in here and show this, here's the plane shows up here. All right, so we'll select that. And chain group 2. This is the second part. Notice how it's already being previewed on the path itself. Inside link and the path alignment plane. We'll get the inside link and it'll be the front plane again. All right. So I don't have to establish the pitch because that's already being established by the distance between the cylindrical faces we've created. Click on Fill Path, and it automatically figures out how many chain links it needs to fill up the path all the way. Now, usually when doing this from scratch, you've got to fiddle with the path length a little bit in order to get the chain to meet perfectly end to end. So, in other words, there might be a situation where you've got some sort of overlap here or a gap between the ends of the chain. On a bicycle, that's taken care of by the spring in the rear derailleur, which winds up the chain to some extent, winds up the extra. But in this case, I've already got those numbers figured out, and what you would have to do would just be to go back and forth between editing the length of the chain or editing some length of an element inside the chain and just doing your fine-tune adjustment there. So that's how the chain pattern is created. You can imagine that before we had this functionality in SolidWorks, it took us a lot of time to make that kind of pattern manually. Okay, another thing that you find in this chapter is about mirroring, and the controls on the bicycle, especially in the handlebars here, we've got a couple of things that require mirroring. So let's take a look at this subassembly. Right click on this subassembly, open it up. Let's see how this is organized. We've got a handlebar. We've got some links for the fork mechanism. We've got a brake subassembly, and the brake subassembly has a left and a right. The parts in the subassembly have to be different from one another for left and right. So let's take a look at how this was done, deleting the already mirrored components. Mirror components, right hand side, components to mirror. Now, for the brake lever assembly, I'm going to create an opposite hand version, which also makes opposite hand versions of the individual components. The grip itself does not need to be mirrored, but the position does not need to be mirrored either. In this case, you could mirror the position but not the orientation, or mirror both the orientation and the position. The other types of methods that you can use for component patterns in assemblies are linear patterns, circular patterns. A pattern-driven pattern is going to be a component pattern that follows a feature pattern. So if all the spokes on the wheel had been the same, we used a feature pattern to create the holes in the rim, and we could have used a component pattern to follow that feature pattern if all the spokes had been the same, but they weren't. Sketch-driven pattern for components works just the same way as sketch-driven pattern for features. You put a sketch point everywhere you want a component. And also a curve-driven pattern would have been how we created the chain-driven or the chain pattern before the existence of the chain pattern. And beyond the patterns, we have mirror components, which we've already demonstrated. So I hope this gives you a good overview of some of the functionality that you can expect in the SolidWorks component patterns and mirroring tools. Best of luck, and thank you for reading.